Topic: Structures. Case study. Study cell phone. Towers noting. Structural elements. Reinforcing. Techniques and design issues. Case study. Examine the features of a school desk. Write a design brief with specifications. Structures. Case study 1. Examine the cell phone towers below and read the text. Visual pollution. When an ugly object stands in a beautiful environment, we say the object causes visual pollution. Some cell phone towers are hidden and disguised as trees. Tower A and B. Structural elements. Cell phone towers are tall, large, and heavy structures. If they are not designed properly, they may break and fall over. A tall, thin tower, Tower C and F, is not very stable. To increase the stability on such a tower, engineers make use of guys. A guy is a structural element made from flexible materials, such as ropes, cables, or chains that are used to hold a structure in place, like in examples C and F. A cell phone tower, Tower D and E, can also consist of a series of columns and beams that are welded or bolted together. The column is the part of a structure that is vertical, upright. A beam is the part of a structure that is horizontal, sideways. A beam is used to span a gap and is supported by columns on either end. Reinforcing techniques. Cross-bracing, left, increases the stability of cell phone tower. Tower D, E, F. A brace is a structural element used to reinforce and strengthen a structure. Stops the structure from being pushed out of shape. Cross-bracing is a form of triangulation. Gusset plates, right, can be used instead of cross-bracing. Gussets are made from strong materials and are used to reinforce and connect different parts of a structure. They are flat and often found in triangular shapes. Base size and a foundation. The base size of a structure, Tower E, is the bottom or footing. The base of a structure should be as wide as possible and the top must be narrower than the base. The structure must also be fixed down to the ground, to the foundation. The foundation is the heavy base, usually made from stone or concrete, that supports a structure from underneath. Center of gravity. If you pull the string in structure 1, it will topple and fall over. When most of the weight of an object is in its upper part, engineers say it has a high center of gravity. Structure 1 is not stable. When you pull the string in structure 2, it will tilt slightly but will fall back to its original position. When most of the weight of an object is in its lower part, the base, engineers say it has a low center of gravity. Structure 2 is more stable. Now, answer the following questions referring to the cell phone towers on the previous page. 1. Why do you think Tower A was designed to look like a tree? 2. Why does Tower C have cables, while Tower D has no cables? 3. Why will Tower A not topple over and fall, even when the wind is strong? 4. Why does Tower D have a large concrete block at the bottom, while Tower E has no foundation? 5. Which of the towers on the previous page has the widest base? Why was it designed to have such a wide base? 6. Which of the towers do you think is most unstable? Why do you think so? To summarize, the following are different ways to prevent towers from falling over easily. Make the center of gravity low. One way of doing this is to connect the tower to a heavy object at its bottom, a foundation. Fasten the tower to the ground with cables, guys. Plant the tower deep in the ground. Give the tower a wide base. Case study 2. Examine the features of a school desk and write a design brief with specifications. Examine the examples of school desks below. Think about how you would design and make a new desk. Write notes and make a few freehand sketches too to help you develop an idea. Design brief. To help you write a design brief, you need to answer these 4 questions. 1. What is it? What is needed? 2. Who it is for. 3. What it is for. 4. Where will it be used? Now you can write the design brief. I'm going to design and make a what is needed. 4. Who. 2. What. It will be used in. Where. Specifications. Specifications are the exact requirements that guide the designing, making, and evaluation process. Specifications give important information about the product that the designer will design. Example: the desk must be made from recycled wood. Materials. List a specification for each of the following. The desk must be. Function. The desk must be. Appearance. The desk must be. Materials used. The desk must be. Size. The desk must be. Shape. The desk must be. Safety.